Hello friends, welcome to Risingpearl.com. Today we are talking about Series 5, where we're learning a great deal on polynomials. This is webisode number 7. Friends, today's topic is geometrical meaning of zeros of a quadratic polynomial. In other words, graphically speaking, what do we mean by zeros of a quadratic polynomial? Now friends, at Risingpearl.com, it is our goal to give you whole perspective, 360-degree perspective of any concept. So we try our best to provide as much detailed clarification as we can for any concept that we discuss. So we also strongly recommend and urge you that if you have any questions that you need clarifications of, please feel free to share them in the comments below with us, and we will do our best to answer, provide those questions, clarifications to you. So friends, let's get started. Now, in order to save some time, we are going to use the same quadratic polynomial that we used in the last webisode, which was x squared minus x minus 6. What we are going to do is, before we understand the zeros of a quadratic polynomial, we are going to first draw a quadratic polynomial, for which we need to get a quadratic polynomial, and I have used the same quadratic polynomial that we used last time. So the value of the quadratic polynomial at each value of x, we are going to represent that by y. So we have drawn a small table here, two rows, and we would want to take some arbitrary values of the variable x, and for each of those values we are going to find out the corresponding value of the polynomial at that value of the variable. In webisode 2 we discussed how to find out the value of a polynomial at a particular value of a variable. I'm going to provide the video link below for your quick reference. Now, why am I taking the same polynomial? Now, it is just to save time. So here in the last webisode, we actually took these values for x, right? So minus 2, x minus 1, x 0, 1, 2, 3, and I think we also did 4. And for x minus 2, the value of the polynomial was 0. At x minus 1, it was minus 4. At 0, it was minus 6. At 1, it was minus 6. At 2, it was minus 4. At 3, it was 0. And at 0, it was 6. The reason I took the same value I took the same polynomial as the last webisode is just that I can get these values quickly drawn out. Right? So I don't have to go ahead and find each of these values, but just from a completion standpoint, for example, for x equals 1, what is the value of px? So the value of y at x equals 1, for example, is 1 square minus x, so x is 1, minus 6, which is 1 square is 1, minus 1, minus 6. 1 minus 1 is 0. This is equal to minus 6, which is what we have here. So I took the same polynomial just to save time, so I don't have to find out each of these values. Now, I strongly encourage you to come up with your own polynomials. You know that the only criteria that you have to get for quadratic polynomial, you need to come up with your own quadratic polynomial, and the only criteria is that the degree of the polynomial should be 2. You can write any polynomial, for example something like x squared minus 6, maybe 2x squared plus 5x. I'm just making some up, maybe this plus 10, or any other quadratic polynomial. I encourage you to come up with your own quadratic polynomials and try out exactly what we are doing in this webisode, and make sure that whatever we find in these videos are actually consistent with what you find for your own polynomials. It'll be actually a great test, right? Now let's quickly draw the polynomial and see how does our graph look like. So what we will see is that here we have drawn on a graph paper, we have drawn the two axes, x, x dash, y, y dash, and this is our origin right over here, right? Now let's first get the tables. So here for x minus 2, x minus 1, x0, x1, x2, x3, and x4. So the value for the px here was 0. Here it was minus 4. Here it was minus 6. Here it is minus 6. Here it was minus 4. Here it was 0. And here it is plus 6. Now we would want to draw out each of these points on our graph. So the first point is this one. At x equals minus 2, the polynomial value is 0. So for minus 2, we go 2 units on the left side of x-axis, on the left side of the origin, and the value of the polynomial is 0. So this point is lying there. So this point actually lies on the x-axis. Similarly, the next point is x minus 1, y is minus 4. So x, we go 1 unit to the left, and y is minus 4, so we go 4 units down. So 1, 2, 3, 4. So this is the point represented by minus 1, minus 4. Similarly, the next one is x0, y is minus 6. This point is on y-axis. So 6 units below the origin. Then we see x equals plus 1, y minus 6. So we go 1 unit to the right side of origin on x-axis, and then 6 units below the origin. This is the point, which is this point over here. And then similarly we draw out the other remaining points, right? So at this, right now we have got all the points that we have seen. Now we would want to draw a curve that passes through each of these points that we have drawn on the graph. So our final graph should look something like this. And it will take you some time, and with some practice you will draw these graphs. They are U-shaped graphs. They are, I mentioned to you the last webisode, they are called parabolas. So parabolas are U-shaped graphs like this. They kind of are in a shape of a U, right? And we talked about in the last webisode why we need so many points. At least I would say, 5, if not 6 or 7, in order for you to draw these parabolas, right? So now I want you to pay particular attention to these 2 points, which is this point here and this point here. That is, now first thing to understand is this graph over here. This graph is the graph of the polynomial x squared minus x minus 6. So similarly, when you take your own quadratic polynomial, you will have your own graph. It will look different from this, but whatever the graph is, this is the graph of your quadratic polynomial, right? And why am I saying pay attention to these 2 points? That is the point where the graph actually cuts the x-axis. This is your x-axis, the horizontal line, and the graph, which is the quadratic polynomial, is cutting the x-axis at these 2 points. So let's write down these coordinates. So this will be, here x is minus 2, y is 0, and here x is 3 and y is 0. So we will come back to why these 2 points are of any significance for us. Now let's do one thing. Let's get back to our polynomial, and this time let's write our polynomial again, x squared minus x plus 6. And this time we are going to find out the 0 of this quadratic polynomial. Now I think it was webisode number 3 where I showed you how to find 0 of a linear polynomial. Now for quadratic polynomial, again it is pretty much the same way, because we are trying to find out what value or values of x that will make this polynomial 0, right? So in other words, we are going to solve this equation, x squared minus x plus 6 equals 0, find out what value or values we see that makes this polynomial 0. We are going to use middle term factorization to do this. And recall, friends, from our last webisodes from our last grade, where we went in details about step by step what is middle term factorization and how do we do it. I'm going to provide those video links below for your easy quick reference. But here I'm going to just assume that you know what is middle term factorization and go from it. So essentially I'm going to try to split this term in the middle into two separate terms, right? So this will become x squared minus 3x plus 2x. So my two terms are, this is the first term, minus 3x, and the other term is plus 2x. This should be minus. I think our equation was minus 6. Minus 6 equal to 0. So now this means, so from the first two terms we will take x common. So we will get x minus 3. And from the second two terms we will get plus 2 common. We will get x minus 3. And this is equal to 0. And from this term and this term we will take x minus 3 common, and then we will have x plus 2 equal to 0. So here what we have, friends, is that we have two factors which is equal to 0. In other words, you can think about this as p times q is 0. So when the product of two numbers is 0, either p can be equal to 0, right? Then doesn't matter what is the value of q, the product becomes 0. Or you can have q equal to 0, it does not matter what is the value of p, because q is 0, then pq will become 0. That means that either x minus 3 is 0, because then the polynomial will become 0, or x plus 2 is 0. That means this is a possible solution, this is a possible solution. So if you solve this, you will get from here x is equal to 3. Simply x goes, the minus 3 goes on the other side of the 0, becomes plus 3. And from here you get x equals minus 2. So in other words, friends, so this is a 0 of the quadratic polynomial and this is a 0 of the quadratic polynomial. So simply if you were to find out the value of the polynomial at x equals 3, just simply put the value, instead of x put 3, you will see this is 0. So that means 3 is a 0 of this polynomial. Similarly, if you were to find out the value of the polynomial at x equal to minus 2, you will see you will still get 0. So for both x equal to 3 and x equal to minus 2, the polynomial is 0. So both of them are zeros of this quadratic polynomial. Now quickly, if you go back and take a look at the graph that we had drawn earlier. So I'm going to go back here. So we just now saw that x equal to plus 3 and x equal to minus 2. These are the two zeros of the quadratic polynomial px, x squared minus x minus 6. And if you look at this graph, you will see that this is precisely where this graph cuts the x-axis. So if you look at this, look at the x coordinate of the point where the graph is cutting the x-axis, minus 2. This is the same minus 2 that you have. Similarly on this side, you get the point where the graph is cutting x-axis is 3, 0. So 3 is the coordinate, x coordinate, and this is 3. So in other words, friends, what this means is that if you draw your graph of the quadratic polynomial, wherever the graph cuts the x-axis, those x coordinates are the zeros of that quadratic polynomial. In other words, if we now go back and take a look at the geometrical meaning of a zero of a quadratic polynomial, we can say that geometrically speaking, zeros of a quadratic polynomial is or are the x coordinate of the points of the points where the graph of px intersects x-axis, as we have just seen. Now friends, also recall a standard way to write a quadratic polynomial is ax squared plus bx plus c, where a, b, c are real numbers and a is not equal to 0. Because a is 0, then the x squared term will go away. It will not be a quadratic polynomial anymore. So if a cannot be 0, now a can be more than 0 or a can be less than 0. In the last webisode we saw that if a is more than 0, now you can get a graph like this, you can get a graph like this, or you can get a graph like this. So what is common in all these graphs is the parabola is facing upwards. Right? The parabola is facing upwards. Now what is important also, we just now saw that if the parabola, if the graph intersects x-axis, the x coordinate of those points are the zeros of a quadratic polynomial. So in this first case, so this and this, the graph intersects x-axis at these 2 points. So these 2 points, the x coordinates represents the zeros of this polynomial, and there are 2 zeros. For this polynomial, the polynomial intersects x-axis only at 1 point. So there is only 1 zero of polynomial. And in this particular case, the graph actually does not intersect x-axis. So there are no zeros of this polynomial. So here we had 2 zeros of a polynomial. Here we have 1 zero of a polynomial. Here there are no zeros of a polynomial. That means at no value of x, the polynomial is 0. Now what about if the graph intersects, if the value of the polynomial or the a is negative? Again, ax squared plus bx plus c, standard way to write a quadratic polynomial. Now what if a is actually now less than 0? If a is less than 0, we know that the graph looks like one of these scenarios. Simply put, the parabola is facing downwards. In each of these cases, the parabola is facing downwards. So if a is negative, if a is positive, the parabola faces up. So if a equals positive, the parabola is facing upwards. If a is negative, the parabola is facing downwards. So in each of these cases, the parabola is facing downwards. But again, friends, notice that in this case, the parabola intersects the x-axis at 2 points. So there are 2 zeros of this polynomial. Here the parabola intersects only at 1 point. There is 1 zero of a polynomial. And here the parabola does not intersect the x-axis. So there are no zeros of this polynomial. So friends, as you have seen, we actually went through a lot of different scenarios. And what have we seen? So we have seen that the zero of a quadratic polynomial, the reason is we calling it zero or zeros of a quadratic polynomial is the x coordinate of the point or points where the graph intersects the x-axis, right? And secondly, which is very important, is that also from the graphs we are seeing that a quadratic polynomial can have either 2 zeros or 1 zero or no zeros of a polynomial, right? So, or in other words, a quadratic polynomial can have at most 2 zeros. This is very, very important, friends, to understand that for a quadratic polynomial, you can have either 2 zeros or 1 zero or no zero. So maximum you can have 2 zeros. And this basically goes to the the fact that the degree of a quadratic polynomial is 2, so you can have at most 2 zeros of a quadratic polynomial. So depending on the value of the a and what your exact quadratic polynomial is, that polynomial, when drawn graphically on a graph paper, will intersect x-axis at 2 points or 1 point, or it will not intersect x-axis at all. And wherever it intersects the x-axis, that x-coordinate is the 0 of that quadratic polynomial. In the next webisode, friends, we are going to start to take a look at subcubic polynomials.